Hi everyone, I am Dr.I.JANNATHUL FIRTHOUSE, Assistant Professor of Mathematics, A.D.M. College for Women, Autonomous NAGAPATTINAM. Today, we will discuss about the topic UV method using Vogel'S approximation in operation research. Now, first of all, you have to find the initial basic feasible solution using one of the transportation problem, the Vogel'S approximation method. So, in this UV method, we have to use any one of the transportation problem, that is a northwest corner rule, least cost method or Vogel'S approximation. Using this method and find the original allocation of the transportation problem. So, first of all, you have to check whether the problem is balanced or unbalanced. So, already I told how can we check 6 plus 1 7, 7 plus 10 17 and 7 plus 5 12, 12 plus 3 15, 17. So, the demand and supply is equal value, that is 17 and 17. So, the problem is balanced transportation problem. So, now we will use one of the transportation model, that is the Vogel'S approximation, to find the original allocation value, and then we will use the UV method. So, how can we solve the problem? So, in each row we find the minimum element and the next another minimum element, the difference between these two minimum elements. So, what is the least element in row 1? 2 is the least element and the next least is 3. So, what is the difference between 3 and 2 is 1. In second row, what is the least element? 0 is the least element and 1 is the next least element. So, what is the difference between 1 and 0? The 1 minus the 0 is, again we are getting 1. And the third row, what is the least element? 5 is the least element and 8 is the next least element. So, what is the difference between 5 and 8? 3. So, likewise, we use similarly for the row. What is the least element in column? First column, 1 is the least element. And the next least element is 2. What is the difference between 2 and 1? That is 2 minus 1 is 1. And the second column, likewise the second column, least element is 0 and the next least element is 3. So, difference is 3 minus 0 is 3. Likewise for third column, least element is 6 and the next least element is 11. What is the difference? 5. That is 11 minus 6, 5. So, likewise, least element is 1 and the next least element is 7. So, 7 minus 1 is 6. So, we compared both the row difference and the column difference. Which one is the bigger? Which one is the largest difference? So, 1, 1, 3, 1, 3, 5 and 6. So, which one is the biggest, largest difference? 6 is the largest difference. So, we choose the fourth column. So, we choose this fourth column. So, in this fourth column, which element, which cell value is minimum? So, 1 is the minimum value. So, the minimum value, the row value is 1 and the column value is 2. So, compare 1 and 2, which one is the minimum value? 1 is the minimum value. So, you have to allocate 1 and subtract column value to the row value, that is 2 minus 1, 1. 1. So, the 1 is vanished. So, the column, second row is to be vanished. Next, step 2. In step 2, the remaining elements. What is the remaining elements? 2, 3, 11, 7 and 5, 8, 15, 5, 8, 59. So, because the second row is to be vanished. So, the demand value is 6 and 10. The supply value is 7, 5, 3, 1. So you have to be check whether the problem is to be balanced or unbalanced. 6 plus 10, 16. 7 plus 5, 12. 12 plus 3, 15. 1 plus 1, 16. So likewise in the step 1, you have to find the difference between the least element and the next least element. So what is the least element? 2 and next least element 3. So difference is 1 and the least element is 5 and the next least element is 8. The difference between these two elements is 3. So only two elements are there. 2, 5. So 5 minus 2, 3. 8 minus 3, 5. 15 minus 11, 4. 9 minus 7, 2. So compared to these differences, row differences and column differences, which is the largest difference? 5 is the largest difference. So we choose the second column. Okay. So along this second column, the 3 is the minimum cell value. So 3, the corresponding row element is 6 and the column element is 5. So which one compared to 5 and 6, which one is the minimum element? 5 is the minimum element. So we have to allocate 5 and subtract 6 minus 1, 5. So 5, the second column is to be vanished because the demand value is to be vanished. Step 3. 2, 5, 11, 15, 7, 9. So 1, 10, 7, 3, 1. So what is the difference between 2 and 7 is 5 because the 2 is the least and 7 is the next least. 5 and 9 is 4 and 5 and 2 is 3. 15 and 11 is 4. 9 and 7 is 2. So which is the biggest difference, largest difference is 5. So you have to choose the first row. So in first row, which cell value is minimum? So 2 is the minimum value. So the corresponding row element is 1 and the column element is 7. Compared to 1 and 7, which one is the least value? 1 is the least value. So you have to allocate and subtract 7 minus 1, 6. So remaining the first column first row is to be vanished. Next step 4. So 5, 15, 9, 6, 3, 1, 10. So only one row and 3 columns are there. So obviously which is the least element? No need to find the differences because only one row is there. So 5 is the least value. So the column value is 6, the corresponding row value is 10. Obviously we compared 6 and 10. 6 is the minimum. So we have to allocate 6. So and subtract 10 minus 6 is 4. So this row, this column is to be vanished. Step 5. 15 and 9, 4, 3, 1. So compared 9 and 15, which is the least element, least cell value? 9 is the least cell value. So the corresponding column element is 1 and the row element is 4. So obviously we have to allocate 1 and subtract 4 minus 1, 3. So these column is to be vanished. Step 6. 15, 3, 3. So the problem is to be balanced. So and put in the one table all the values. 2, 3, 11, 7, 1, 0, 6, 1, 5, 8, 15, 9. So what are the allocations? So first one, the original allocation. 1, 5, 1, 6, 1, 3. So you have to check whether the allocation is correct or not. So what is the formula? M plus n minus 1. The m means number of rows and the n means number of columns. So how many rows? 3 rows plus 4 columns minus 1, 7 minus 1, 6. So 1, 2, 3, 4, 5, 6. 6 allocations are there. So now we have to use the UV method to find the optimum basic or feasible solution. Now we find U1, U2, U3, V1, V2, V3, V4. In all the problems on UV method, we assume that the initial value, that is the U1 value, is to be 0. And using these values for the original allocation, we find the dummy allocation for the unallotted cells, that is the 11, 7, remaining original allocation, that is the original allocation is not there. We find the dummy allocation using the initial value U1 is equal to 0 using the original allocation, that is, so 2, the cell value is 2, initial U1 is equal to 0, that is 2 minus 0 is 2 for the values of V1. So that is the remaining second cell value 3, 3 minus 0 is 3. So by using the value 2 with the help of the original allocation, that is the 6. So the cell value is 5. So 5 minus 2 is 3 for U3. And using that value U3, the original allocation 15 and 9. So 15 minus 3 is 12 and the 9 minus 3 is 6. So using the V4, that is a 6. So original allocation 1. So 1 minus 6 is minus 5. The cell value minus that value. Okay. So now we find the dummy allocation. So which place is there? That is U1 plus V3 minus C13. U1 value is 0 plus V3 value is 12 minus C13 is 11. That is 12 minus 11, 1. The dummy allocation. Next value for the 7, that is the place U1 plus V4 minus C14. U1 0, V4 6 minus C14 7. So 6 minus 7 is minus 1. And similarly for 1. Second row, first column, that is U2 plus V1 minus C21. So U2 is minus 5 plus V1 is 2 minus C12 is 1. That is minus 3 minus 1 minus 4. Similarly for U2 plus V2 minus C22. U2 minus 5, V2 3 minus C22 0. That is minus 2. Minus 2. Likewise, for the element 6, that is the place for U2 and V3. U2 plus V3 minus C23. U2 minus 5, V3 12 minus C23 6. That is 7 minus 6 1. Likewise, another element 8, that is U3 plus V2 minus C32. So U3 3 plus V2 3 minus 8. 6 minus 8 minus 2. Okay, so we fill the unallocated places using this value u1, u2, u3 and v1, v2, v3, v4. We find the dummy values. So, among these dummy values, we select the positive value and each edges ends with the original allocation. So, we have the two positive values, we select either one. I select that value because the loop ends with the original allocation. So, starting that point, corner end with the original allocation and this value. So, theta minus, theta plus, theta minus and theta plus. So, to find theta is equal to minimum of 1, 1, 3. 1, 1, 3. So, minimum value is equal to 1. So, theta is equal to 1. Now, we put the another tabular column. Two, 3, 11, 7, 1, 0, 6, 1, 5, 8, 15, 9. Only we put only the original allocation. Undisturbed original allocation. 1, 5, 6. Okay. So, what is the theta? Theta is the minimum value of the original allocation. Theta is equal to 1. So, theta plus, theta minus, theta plus, theta minus. So, instead of the dummy allocation, we put the original allocation for theta. What is the value of theta? Theta is equal to 1 and theta minus. So, the original allocation is 1. So, 1 minus 1, 0. We need not to put here. The another original allocation is 3. That is theta minus 3 minus 1, 2. Another one is theta plus. That is 1 plus 1, 2. How can we check? N plus n minus 1. 4 plus 3 minus 1, 7 minus 1, 6 original allocation, 1, 2, 3, 4, 5, 6. Likewise, in the previous steps, we find the dummy values. So, u1, u2, u3 and v1, v2, v3, v4. So, in all problem, we assume that u1, the initial value, u1 is equal to 0. Using the original allocation, we find v1 and v2. That is the cell value minus the assumed value. That is 2 minus 0, 0 and 3 minus 0, 0. And the original allocation 5 minus 0 is 5. Using that value, so 15 minus 5 is 10. 9 minus 5 is 4. That value 6 minus 10 is minus 4. So, we find all the values for u1 up to v4. So, now we find the dummy allocation likewise in the previous steps. u1 plus v3 minus c13. u1 is 0, v3 is 10, minus 11. That is minus 1. Next for this, u1 plus v4 minus c14. 0 plus 4 minus 7, that is minus 3. u2 plus v1 minus c21. That is u2 minus 4 plus v1 0 minus 1. That is minus 5. u2 plus v2 minus c22. minus 4 plus 0. So minus 4 is there. U2 plus V4 minus C24. U2 is minus 4, V4 is plus 4, minus 1. So answer is minus 1. The remaining 1 values is there. So U3 plus V2 minus C32. U3 is 5, V2 is 0, minus 8, that is minus 3. So all the values of the dummy value is all negative. So the problem is to be over here. Now you multiply the dummy original allocation and the cell value. That is 1 into 2 plus 5 into 3 plus 1 into 6 plus 6 into 5 plus 2 into 15 plus 2 into 9. 2 plus 15 plus 6 plus 30 plus 30 plus 18, 60, 78, 78, 84, 94, 99, 101. The optimum basic feasible solution is 101. Now I hope you all understand the UV method using Vogel'S approximation. In next class, we will see the another method in operation research. Thank you guys.